All right, here we go. This is number 2. So we're still continuing this review test thing. What's your first guess on this? What do you, I mean, yeah, you got a factor, okay? So let's see if this will factor. Now this factoring is a little bit harder than the one we did yesterday. Remember the one we did yesterday had all pluses in it, okay? So look, when you multiply them together, you get -10. So if I multiply two numbers together and I get a negative number, what does that mean? I mean, one has to be what? Positive, and one has to be negative, right? And they have to add up to be a +3. So yeah, 5 and 2. So this will be a +5 and a -2. And then this will just be z. Okay, z and z. Right? Because they multiply to be -10, they add up to be +3. We do the same thing down here. Usually I put the z's first. And then let's do the signs. Look, this is positive right here. So that means when I multiply two numbers and I get a positive number, I got two options, right? They're either both positive or what? Both negative. So which one? Both negative, because when they add up, they have to add up to be a negative number. So I can't take two positive numbers, add them together, and get a negative, can I? So they got to both be negative. All right? So now I got to figure out what times what equals 4. Well, I got 4 times 1, and I got 2 times 2, right? So, yeah, I'd go 2 and 2, wouldn't you? Right, because it multiplies to be +4 and it adds up to be -4, because -2 plus -2 is -4. Right? That was the hardest part about the whole problem right there, was the factoring. Okay, this part, the simplifying, is the easy part. Look what happens. Z minus 2 on top cancels out with one of these. Z minus 2's on the bottom, and I'm done. Right? Z plus 5 over Z minus 2. There it is. So if you know how to factor, this problem's not difficult. If you know how to factor. Okay, that's really what this is teaching, isn't it? Just basically how to factor. The canceling out thing was no big deal, but the factoring was the key to this problem. All right, let's do a couple more. 8 or 9? Okay, we did 9 yesterday, didn't we? So let's do 8. Tuesday. All right, here we go. Oh, this actually is pretty easy, isn't it? Okay, watch. That's your division right there. I just made it a little thicker. Okay, so that's your division. So you got a top divided by the bottom. Well, we don't, in fractions, we don't really divide, do we? We always change it into a multiplication problem. So you keep the top the same, and what do? You multiply by the, what's the word? Reciprocal, okay? You can say inverse, I guess, but I always say reciprocal. Multiply by the reciprocal. So the reciprocal means you take this and you flip it. So I've got an x plus 4. Do you need to get a drink of water or something? So, and then this is over 4. Everybody with me? Does anything cancel out here? Does this 4 cancel out with this 4? No, because this 4 is being added to something, all right? And it won't cancel out. So there's nothing really that cancels out at all, is there? So you just multiply across the top, multiply across the bottom. Now look, if I'm taking this x and I'm multiplying it by this, I got to put that sum in parentheses. So how do we write that? We write x times x plus 4. If you wanted to distribute it, I guess you could. You don't need to. Just keep it like that. I would keep it like that. And then you multiply the bottom. And that's it. You're done. Yeah, I said you could distribute if you wanted to. Okay, it'd just be x squared plus 4x over 12. Either one of these is acceptable, but why bother going from here to here? You know what I mean? It's just an extra step. Just keep it like that. We good? That's all that's testing, is just to make sure you know division is the same thing as multiplying by the reciprocal. Okay, let's keep going. What else? What about 10, 11, 12? 10? Okay. All right, now if I have a negative exponent right here and I got a fraction in that parentheses, do you remember the little trick we did with this? We're not going to take this whole thing and flip it to the bottom. I mean, we could, And we showed you how to do that, or I showed you how to do that when we first went over these. But there was a little trick when you had a negative exponent. Instead of taking this whole thing and flipping it, what can I do? Big hint, right here. No. No. You guys don't remember this? Come on. Look, instead of taking the whole thing and taking the inverse or the reciprocal, right, or taking it and flipping it down to the bottom, what do we do with that? What's really the only thing I can do with that? I do what? Instead of flipping it down, instead of doing this and taking this whole thing and flipping it down to the bottom, I just take this fraction and flip that. Right, take the reciprocal of this. So watch, I take the reciprocal of this. Is that not... You guys act like this is the first time you've ever heard this. Come on, we've done this. And you're the one, I remember, you're the one that when we first started doing this, you were catching on, and every time when I ask you a question, you're like, yeah, flip the fraction, flip the fraction, flip the fraction. I remember you saying it a bunch of times. And you don't remember it?
I was about to say, when you put that smirk on your face.
So flip the fraction, and then what do? We don't keep it to the negative fourth. If I flip this, I got to change this as well, don't I? So what's this going to be? 2 to the what? 2 to the fourth. So really that thing right there is just 2 to the fourth, which is 16. Right? Okay, let's do another one. We're going to do that same process. What's that? It's a long time ago, is that what you said? Well, you're supposed to be keeping up with this stuff. That's right. Watch the videos, and it won't be a long time ago. Here we go, look. We got a fraction again, and it's being taken to a negative exponent. So, was it that long ago the last time we talked about this? No, it was about 5 seconds ago. All right, so what do? Right, make it 25 over 4. We'll flip that, and then we'll take this to what? To the positive 3/2 power. Now, we got an extra step that we didn't have over here. That's why it's a separate problem. Now, we got to remember a little trick for this. Instead of taking it to the 3/2 power, I'm going to take 25/4 to the what first? I'm going to split this 3/2 up into two numbers. I'm going to first of all take it to the what? 1/2. Good. Take it to the 1/2 power, and then I'm going to take that whole thing to what? To the third. Now they rigged this thing, obviously, didn't they? They used 25 and 4 for a reason. Because what is 25 to the 1/2 power? It's the same thing as saying what? Square root. It's not half of it, it's the square root of it. It's to the 1/2 power. It's not times a half, it's to the 1/2 power, which means the square root of it. So, what's the square root of 25? 5. What's the square root of 4? 2. So, that is 25 over 4 to the 1/2 power. It's the same as 5 over 2. Right? But I'm not done with it. What do I got to do to that thing? I got to take it to the third. So, let's go ahead and do that. Let's go 5 cubed. You can do that in your head. 5 times 5 is 25. 25 times 5 is 125, right? $1.25. Remember talking about that? Going to the Coke machine? Okay. And then we go 2 cubed, which is 8. There it is. It's not hard to do. It's just you got to remember the steps. You got to remember this stuff, which means you got to review. All right? Yep. I mean, what other class are you taking where if you don't know something, you can just hop on the computer and bang, it's right there? Is there any other class that you're taking you can do that? No. This is the only one. All right? Take advantage of it. All right? Go through your lessons, and if you see some stuff, I mean, look, it's only 3 sections, 1, 5, 1, 6, 1, 7. Of course, it took like a week and a half for each of these sections to go over because they are a little bit long. All right? They pack a lot of stuff into these sections. That's why it's college algebra. It's not high school algebra, okay? Because they put a lot of stuff in here. So anyway, there you go. What else? Like 12 you should be able to do now, right? Because we basically did that same step on 11. You'd go 27 to the 1/3, right? So it's the cube root of 27, which is 3, then you take 3 and you take it to the 4th power. Can you go 3 to the 4th in your head? We've talked about that before. Because 3 squared is 9 times another 3 squared is 9. 9 times 9 is 81. So 3 to the 4th is 81. So you could do that whole thing in your head, couldn't you? All right. Let's see. We did 13 or 14 yesterday, didn't we? Wasn't that one of the last ones we did?
We did 14, but we went back. We finished it.
I finished it. Yeah. Look on the YouTube. 13 is pretty much just like it. I don't think I have to do 13. What about 15? What do you want to do 15?
Can we do 16?
Yeah, we definitely want to do 16. Let's do that. And you can decide if you want me to do 15 or not. Let's do 16. Okay, what do we got? M to the negative first minus n to the negative first over mn parentheses to the negative first. All right. Now look, our first gut instinct is to take this first m to the negative first and chuck it down to the bottom. But we don't do that. Why can't we just take this m to the negative first and throw it down to the bottom and make it m to the first? Because what do we have up top here? We've got a subtraction, that's right. Okay, so these are not individually being multiplied times stuff, right? This is part of a sum. It's part of a subtraction or an addition problem. So you can't just separate it and take it and throw it to the bottom. Make sense? So what do? We just work with it up in the numerator. So what I'm going to do is I'm going to take this, pretend that nothing else is there. Just take this. If I just had m to the first and nothing else was on this page, how would you simplify m to the negative first? Well, yeah, you're right, but not put it over 1, but put 1 over m. That's right. Okay, so m to the negative first is 1 over m. That's what I'm going to do right there. See it? I'm not taking this and chucking it to the bottom. I can only do that if that thing is only being multiplied by something else. All right? It's not. It's being, you're subtracting something from it. So I can't separate it from this subtraction. Everybody see that? So I can't separate it from the subtraction, or if it was an addition, right? It'd be the same deal. So, but I can take m to the negative first and make it 1 over m, right? There's a minus in between, right? So I still really haven't separated it, have I? All I did was change m to the negative first. Well, what do you think n to the negative first is? That's 1 over n. Good. You with me? Now what I'm going to do is I'm going to take this right here. I'm not going to flip it to the top. Now technically you could. All right, if I put this in parentheses, I could take this and put it up to the top. I'm not going to. I think it'd be more confusing than anything else. What I'm going to do is kind of what we did here. If this was the only thing on the page, mn to the negative first, how would you rewrite that if that was the only thing on this whole page? 1 over mn. That's right. So that's what I'm going to do right here. I'm going to write 1 over mn. Make sense? So all I did was take all these things individually. Do you see it? And I just changed it so I don't have a negative exponent. I didn't flip it to the top. I didn't flip it to the bottom. I just kept it where it was, but I made it 1 over m, 1 over n, 1 over mn. Now we don't have to worry about any negative exponents, right? It's kind of nice. But we got another problem. We got fractions here, though, don't we? Right? Which is not that big of a deal. We got to find a common denominator. We're going to subtract those fractions from each other. So what's the common denominator if you have an m and an n? It's just mn, easy. Now look, what'd you do to m to get to mn? Multiply it by n, so you do the same thing to the top. So you multiply that by n, which will give you an n. Right? What'd you do to n to get to this? Multiply by m, so you do the same thing to the top. Multiply that by m. We good? Now we don't mess with the bottom, we'll just keep that right there. So all we did was a simple little common denominator thing. Found our new numerators. Now we're ready to simplify this. Okay, we did one just a little bit earlier when you had a division problem. What's division? When you have fractions, what do you do for division? You multiply by the reciprocal. So keep the top the same, n minus m over mn, and you multiply by the reciprocal of this. What's the reciprocal of that? That's right, it's mn over 1. Now, works out real nice and easy, doesn't it? Look, this mn, well, this mn right here is being multiplied by something, isn't it? All right, so I can cancel this out, they divide out to be a 1, and what's my answer? N minus m. Just like that. It's not so hard, is it? Just got to know what to do. You got to know where to start, okay? Don't take this and flip it to the bottom. That's what people have a tendency to do on this. All right, just keep it up to the top, make it 1 over m, and you saw what we did there. We good? All right. All right, 17 through 20 is kind of like the stuff you just had on the quiz, isn't it? So was there one of those that you want to go over? Pick one just for fun. 18. So it's 4 cube root of 5 plus 3 cube root of 135 minus the cube root of 40. Well, we want to simplify these cube roots, don't we? All right. Now, I might not be able to do that right in my head. Now, this one, I can't really simplify that, so I just write 4 cube root of 5. Remember what we do? Come over off to the side, and we do these. So let's think of what's 135. 5 goes into it, right? How many times does 5 go into 135? Somebody do that. How much? Once? 5 goes into 135? No. Well, there's 1 5, but how many times? 27. Okay, so 27 times 5. Who's got a calculator? Use that leopard calculator. Did you make that cover yourself, or is that?
Yeah, it's
Did, okay.
Yeah,
It's duct tape?
Yeah.
Did you color it yourself, or? Oh, it's just duct tape that looks like that?
Yeah.
Okay. All right, so what is it? What is it? 9 times, or it's 27 times 5?
Yeah.
Okay, so 27 times 5, right? And remember, we're taking the cube root, aren't we? If you wanted to, you could just keep it 27 times 5, because what's the cube root of 27? It's just 3. So it's 3 times what? The cube root of 5. Okay? So, plus. But look at this. You already had a 3 out in front of this, didn't you? So what am I going to do? Let's do this in the same step, okay? I don't need to rewrite an extra step. I got a 3 out in front of this, but I'm multiplying it by this thing right there. So I got to multiply that 3 times 3, which is 9, right? Cube root of 5. See that? Okay, minus. Okay, let's take 40 and break that down. It's the cube root of 40. Whoops. I don't need to write the 40 there, do I? Okay. I don't know. What do you got? 8 times 5, right? You could have gone 4 times 10, right? You could have gone 2 times 20. 8 times 5 is good because look what you can do. You can take the cube root of 8. So what's the cube root of 8? It's just 2, right? That should be something you see in your head, right? And then it's the cube root of 5. So there's a 2 cube root of 5. Now this is not being multiplied by anything else, is it? So what do I write? I just write 2 cube root of 5. Now look, these are all like terms, aren't they? How about that? Isn't it amazing how it just happens to work out that way? Yeah, it's amazing that the author of this problem made it, come out so they're all the same term. That's exactly what happened. So look what we have. We got 4 plus 9, which is 13, minus 2, which is 11. No, not square root. Cube root of 5. And there it is. Okay, you just got to make sure you remember how to simplify those things. You okay with that? Tell you what, let's do number 20 just for fun. We're doing a lot of things for fun today, aren't we? Can I fit it all on here? I think I can, because there's not much to this, is there? Watch, here it is right there. It's the square root of x over 8 minus the square root of x. So I got to get rid of this denominator. How do I get rid of a denominator that looks like this? No, I shouldn't say that. I said that wrong. You don't want to get rid of the denominator. You want to get rid of the root, the radical in the denominator, because it does say rationalize the denominator, doesn't it? Okay. So how do I get rid of that radical? By the conjugate. And what is the conjugate? It's not the same thing, is it? I don't know who did it. I just remember somebody multiplied by the same exact thing. You don't multiply by the same exact thing. You put a plus in between, right? You change the sign. That will get rid of the square root. If you do that to the bottom, you do that to the top. Because really all we're doing is multiplying by a 1. And let's see what we get. Let's do the bottom first. Try to squeeze this in here. 8 times 8 is 64. Negative times positive is negative. Square root of x times square root of x is x. We good? And then what about the top? Go ahead and distribute it through. So it's going to be 8 square root of x plus, square root of x times square root of x is x. And there it is, right there. Looks complicated at first, isn't it? But it really wasn't that bad. You got to know how to multiply by the conjugate. You got to put a plus sign in here. I don't know what else to do to get you to remember that. But the conjugate, it's the opposite sign. The sign in the middle is opposite. Everything else stays the same, but the sign in the middle is different. Okay? All right, well, that's good enough. I'm going to give you one more of these review sheets. All right? It's almost identical to this with that program that I have that came with the book. All I do is click one button that says regenerate values. It takes all the problems I already picked, and it just makes the problems, just throws different numbers in there. That's all it does. All right, so that's how I can have part A and part B pretty easy. So I'm going to give you part B tonight. Do it over the weekend. Monday's our last day to ask any questions. All right, so make sure that you really work on it. What I would do is this. I mean, you've already gone through part A. All right, maybe review it a little bit more, maybe not. It's up to you. But then take part B tonight. Sit there, set a timer, 45 minutes, all right, or 40 minutes, and sit there and put yourself under a little bit of pressure, all right? It's good to practice under pressure, all right, because then when you get in the test day, you're used to it, you know, you kind of know what to expect, and so you get on there and you take the test. Get in a room where it's completely quiet. Don't listen to your radio. Don't have the TV on. Get somewhere where you just take 40 minutes and you sit there and just answer all the problems, all right? Try it that way and see what happens. And then on Monday, I'll read off the answers and we'll see how it goes. You know what I'm going to do, actually? We got some time. I'm going to go and I'll copy the answers for you. All right? So that this weekend, sometime this weekend, whether it's tonight or tomorrow or Sunday, do the test. Then after you're done, go ahead and grade it yourself. Right? Don't do a problem, look to see if you got it right, and then go to the next problem. Take the whole thing, right? Just like you're taking a test. And then you go back, you look at the answers, and then you see what you did wrong. If you got problems wrong, then go correct them, right? And just like we would do in here. Put yourself under the same circumstances as you would when you're taking a test in class. Because people tell me all the time, well, I have test anxiety. I don't know how to take a test. You know, I don't take tests very well. Well, it's because you don't practice. Because people don't practice putting themselves under pressure. Okay? And that's the honest truth. You got to put yourself under some pressure. And when the bell rings for 40 minutes, then end it. If you're not done, then just mark it wrong. You know what I mean? And then see what kind of grades you get. All right, enough of that.